Okay, so we're here again with another CSEC physics worked example. My name is Junior Roberts. So let's get into the video. So this question here says that a police recruit, while training, shot at a stationary target of mass 5 kilograms with a bullet of mass 0.1 kilograms. The target was mounted on low friction wheels, and as soon as the bullet struck the target with the embedded bullet sped off with a velocity of 6 meters per second. So this question wants us to do a couple of things, and the first thing it wants us to do is to calculate the velocity of the bullet just before it hit the stationary target. So let's see if we can get a quick sketch of this setup here. So here's a quick sketch which as best as I could illustrates the happenings of this bullet and target. So essentially what happened is that the bullet left the gun, hit the target, got embedded in the target, and as a result of embedding itself in the target, both the bullet and the target sped off, the question said, with a velocity of 6 meters per second. So 6 meters per second. So we want to know the velocity of the bullet just before it hit the target. So to do that, we will consider the principle of conservation of momentum. And what the principle of conservation of momentum says is that for an isolated system, the total momentum before collision is equal to the total momentum after collision, right? So basically it is saying that the momentum, so let me write momentum before must be equal to the momentum after, right? That's our principle of momentum. So what it is saying is that the total momentum of the system before collision must be equal to the total momentum of the entire system after collision. So in our system, we had a bullet moving with some velocity and a stationary target, and then after the impact each other, the bullet and the target move off with a common velocity of 6 meters per second. So to work this question, we're going to consider a formula for the conservation of momentum, and we're going to write that formula as m1 u1 plus m2 u2 is equal to m1 plus m2 times common v, right? A common velocity. We could say this is v, right? Capital V, right, for a common velocity. So what we're saying is that the mass of object 1 times its velocity plus the mass of object 2 times its velocity is equal to the mass of object 1 plus the mass of object 2 times the combined velocity of both mass 1 and mass 2. So let's denote. So let us say our bullet, let us say m1 is equal to our bullet. Alright, so m1 is the bullet, m2 is the target, u1, which is initial velocity of m1, is unknown. That's what we're trying to find. And u2, well, first of all, we wouldn't have any u2, we would have a combined v, because it says that both objects move off with the same velocity. So v in this case is 6 meters per second. So we're going to use this information here to help us to solve this question. So taking M1, which was 0.1 kilogram, let's double check. So the mass of the bullet is 0.1 kilogram, so we're going to take that. So we'll say 0.1 kilograms multiplied by U1, which is unknown in this case, plus M2. M2 is the mass of our target, and the mass of the target was 5 kilogram. So we have 5 kilogram, and it says that the target was stationary, so the velocity would be 0 meters per second, and that is equal to the mass of the bullet, which is 0.1 kilogram, plus 5 kilogram times V, and in this case V is 6 meters per second. So 6 meters per second. Alright, so now we can start to simplify. So we have 0.1 kilograms times U1 plus 5 kilograms times 0 kilogram gives us 0 kilogram meters per second. 0.1 plus 5 gives us 5.1 kilograms, and we're going to multiply that by 6 meters per second. So when we take this, well, this would be 0.1 kilograms times U1 equal to 5.1 times 6 gives us an answer of 30.6 kilograms meters per second. Now, since we're interested in finding U1, we'll say that U1 is equal to 30.6 kilogram meters per second divided by 0.1 kilogram. Now, when we plug this into our calculator, we get an answer of 306 meters per second, and this right here is our final answer. Right, so the velocity of the bullet just before it hits the target, let us say this is our bullet, the velocity of it just before it hit the target was 306 meters per second. So again, this was Junior Roberts. If there was anything in this video that you wish to get further clarification on, please post it in the comments below. If you like this video and you think others might benefit from it, please consider sharing, hitting the subscribe and the bell notification so you will be updated whenever I post new videos like this. Thank you for watching.